Okay, so next we're going to talk about Lewis structures. So these are just a 2D representation of a molecule's bonding structure. So how are the pieces put together? How do we draw that on paper? How do we represent that? Well, one way is a Lewis structure. So you can get more complex. It's like some 3D modeling software. You can put together molecules. I actually have a tool that will be able to do that on the Moodle page. So you can play around with that. You can rotate around 3D space. But that's really more the next chapter. So for now, this is just kind of like a road map, you know, just a very rough, like more like actually like if anyone's ever seen like a subway map. It doesn't really represent the reality of the space around it, but just the reality of the subway route. You know, those stops aren't necessarily equidistant. The roads don't line up perfectly with what they're showing around it, but it's just a way of conveying information. And so that's what a Lewis structure is. And as an example here of what one looks like, we've got NH3 right here, ammonia. So if you have cats, you definitely know the smell. If your neighbor has too many cats, you also know what this smells like pretty well. Now, it has 3 hydrogens and a nitrogen. And you know, this tells us the pieces, right? This is the formula. But how are they put together? Where are the electrons in this bonding structure? Well, that's what our Lewis structure right here shows us. So we have a nitrogen in the middle. Generally, we have the thing that makes the most bonds in the middle. That's a pro tip for you. We'll talk about that more in a little bit. And it's making a bond with each of the hydrogens. And so what these are bonds. And each of these bonds, each of these lines represents 2 electrons. So we have 2 electrons being shared between the nitrogen and the hydrogen to the right, 2 electrons being shared between the nitrogen and the hydrogen on the left, and 2 being shared up down here. But we also have this right here. We have these 2 electrons that are not being shared, that are only on the nitrogen. We call this a lone pair. And so these are electrons, or I should say valence electrons, that are not shared. And these are bonding electrons beneath. I forgot to write that before. So we have bonding electrons, we have non-bonding electrons, we have lone pairs. So that's what we're looking at here. Now I just happen to know how to draw these very well. I have at least 25 minutes of experience. And someday you guys will as well. But this is what they look like. But how do we go about drawing them? So how to draw Lewis structures. So there's going to be some details that we add later once we start talking about formal charge. But step 1 is just going to be draw the atoms with all valence electrons. So, hydrogen has 1, nitrogen has 1, 2, 3, 4, 5. Hydrogen has 1, hydrogen has 1. Now I have been a little bit sneaky. I've put my dots in convenient places. But we just use the periodic table. We just look up. We see nitrogen has, make that N a little cleaner. Sure, that's a cleaner N. 5, so we put 5 around. We just count left to right. 1, 2, 3, 4, 5. We get to nitrogen. We go 1, 2, 3, 4, 5. Hydrogen, 1. Boom, we're at hydrogen. 1 dot. So it only has 1 valence electron. Its only electron is its only valence electron. All right, so step 2. We're going to form bonds to complete valence shells. But there's going to be an easier way to state this. So we're going to form the bonds, we're going to complete the valence shells. Well, guess what that means? Much easier way of saying this. So this is what, formally we're doing. What does that mean? Well, hydrogen, if you look at our periodic table, needs 2 electrons to fill its shell. Nitrogen needs 8. To make a bond, each side has to pitch in 1 electron. So what I'm essentially saying is connect the dots. All right. We leave lone pairs alone. We don't mess with those. So any unpaired electrons, we match between the elements. And so let me copy what I have above. Boom, boom, boom. Boom, boom, boom. So exactly what I have above. What does it mean I do? Well, here's an unpaired electron. There's an unpaired electron. Here's an unpaired. There's an unpaired. Boom, boom. Now I have 2, 4, 6, 8 electrons around nitrogen. I have 2 around this hydrogen, 2 around this hydrogen, 2 around that hydrogen, and you know, it matches our answer from before. So that works beautifully. So you just connect the dots. There should be no unpaired electrons when you're done. Something squirrely has happened. You misread the problem, I miswrote the problem, you misread the periodic table, something like that happened. So, you know, watch out. There should be all paired electrons. Everything should have a complete valence shell when you're done. Now, a couple notes about this process. So all valence electrons should be shown or present in the final structure. We don't lose any electrons. We don't gain any electrons, you know, unless it's one of those pesky polyatomic ions. But we'll talk about that in the next video. All right, and if there are lone pairs, right? So like, for example, here, we have a lone pair. Those should be on the more electronegative element. So they need to be on the more electronegative element. And often just, you know, as you go left to right, bottom to top, you get more electronegative. That'll often do the trick, but if worse comes to worse, you can look at the electronegativity table, table 8.6 in your textbook, get the numbers, make sure you're putting the lone pairs in the right spot. So if you look it up, you'd see hydrogen is less electronegative than nitrogen, so nitrogen would get the lone pair, but also it makes no sense for hydrogen to have the lone pair because it doesn't need more than 2 electrons. So if it has a lone pair, it's not making a bond. So that kind of helps you out too. Hydrogen's kind of like a, you know, it's into the line, it's a cul-de-sac, one-way ticket. You make one bond to hydrogen, it's done. We can have more complicated structures where maybe we have multiple central atoms, things like that. We're not going to worry about it right now. This is just an introduction. So again, this is just a 2D representation. So it just shows how the pieces are connected to each other. So before all we care about were what are the pieces, now how are they put together? In the next chapter, we'll carry this further and go, what does that look like in 3D space? So right now we're only doing 2D representations. Now, I'm going to show you one last detail about this, and that is the Lewis structure for ionic compounds, because people often mix up this. It's much simpler. So give me a second, I got to clean off the board, and then we'll talk about it. That trick's never getting old, let me tell you. The power of editing is amazing. All right, so you guys don't get to watch any video of me erasing the board. I know that'd be exciting. All right, here's the first rule. Those lines represent chemical bonds that we drew earlier. Those chemical bonds are shared electrons. Ionic compounds do not have shared electrons. So the first rule, do not draw bonds. So don't, well, big capital R, this is all capital letters. Don't draw bonds. Don't do it. No lines. There is no sharing of electrons. That's why I wanted to break this out. So for example, you all know what's coming. You all know this is going to happen. NaCl, a compound I work into every single chapter of this textbook. If you were to take all of Gen Chem with me, you will see 21 chapters or something like that of sodium chloride. That's what you get. All right. So here's our Lewis dot structures of just the elements. Whoops, there should be an L there. All right. So sodium has 1 valence electron, chlorine has 7. The reaction happens. This electron moves over like so. We get Na plus. We get Cl with 8 dots and a minus. That's it. That's your Lewis structure. All of our valence electrons are accounted for. Just make sure you write your charges. That's it. Your cation has emptied its valence shell, the anion has filled it. Bada bing, bada boom. That is all there is to it. So no lines. How do you know if it's an ionic compound? We got a metal right here. Sodium's on the left side of the periodic table, left of that staircase. So it is a metal and a non-metal. That is an ionic compound, barring some very weird scenarios. So don't draw a line. Sodium is not sharing that electron with chlorine. Chlorine is not sharing one of its electrons with sodium. Sodium doesn't have that kind of pull, it doesn't have that kind of weight. It doesn't have enough electronegativity to do that. It just gets its electron taken. And what holds them together? Opposites attract. That's what happens. So this is the end of the introduction of Lewis structures. We are going to talk about formal charge, which is going to build on this more. And we are basically going to have a nice little funeral for the octet rule. So it'll be a somber affair, but that's the end of this. So stay tuned for the next video.